Hello everyone and welcome to a new IBM RPG sample video. Have you ever struggled with slow queries or huge tables in your IBM database? Well, today I'll show you how to fix that with a powerful feature, table partitioning in DB2. This technique can dramatically improve performance when working with large tables. So let's go. When working with large tables on the IBM, partitioning becomes a critical performance optimization tool. As tables grow over time, millions or even millions or billions of rows, queries, maintenance tasks, and backups can become slower and harder to manage. Partitioning helps solve this by splitting a large table into smaller, more manageable parts called partitions, based on criteria like dates, regions, or customer groups. Why is this important? Well, because each partition can be processed independently. For example, queries will be faster since DB2 will scan only the relevant partition instead of the entire table. Well, let's start creating a simple table in DB2 for I. Let me write the definition of my table, employees. We are going to have an employee number, also we're going to have a first name, last name, salary, and my primary key is gonna be the employee number. Okay, so we can run this query and the table is created. Well, partitioning works whether the table is empty or has existing data. Okay, so let's insert some sample records. I have them in other screen. We are going to copy it and paste here. Okay, we're going to add this 1, 2, 3, 4, 5 records. Okay, so now we have in my table we have all this data into my table. Okay, well, in DB2 we have two methods available for partitioning. Let's talk about them. The first method is using range. This is ideal when data naturally fits into numeric or data ranges. For example, salaries, years, dates, or in our case, the employee number. Okay, an example how we can partition this table into different partitions using range should be this. Let me go to the definition. We must add this after the table definition. Okay, well, we are going to create 3 different partitions for the table. Okay, partition by range. We are going to use empnum, that is the field that we are going to use for partition the table. Okay, and well, we are going to create the first partition that is going to be starting from min value ending at 500 inclusive. Okay, this means that we are going to create a first partition from the minimum value of the employee number to 500. Okay, let me add a name for the partition, port 1 for example. Okay, a second partition, port 2, starting from 501 ending at, for example, 1000 inclusive. Okay, and the third partition that is going to be starting from 1001 ending at max value. Okay, well, this way the different employees will be stored in a different partition depending on the employee number. If we had data inside the table before partitioning, then the data will be stored in the correct partition. If we are inserting new data, the database will store it automatically in the correct partition too. Okay, so we can run this query. Now the table is created again, replaced it, okay, with all this data that was inside, but we can do this and we are getting the same result. Okay, well, what can happen this way? Well, imagine we have a lot of employee numbers between 1 and 500, but there are not many of them with larger numbers. Then we will have more data in some partitions than in the others. So we are going to have unbalanced partitions. Okay, well, let's talk about the second method, that is using hash. Okay, imagine we need to distribute data evenly across partitions. In the example before this, we had this problem, okay, and this way we can solve it. This is also a fantastic option for random access to the table where the data does not naturally group. The problem of this option is that every row will be stored in a partition automatically without our control. So in our example, we will not know where a row is going to be stored. Okay, to do this, we must create the table this way. Instead of using this, we will need to do something like this. Partition, let me write it in caps, partition by hash enum into, for example, into 4 partitions. Okay, so if we run it, okay, in this case we are now creating 4 different partitions, and the rows will be distributed in different partitions depending on the hash calculated over the employee number. Okay, well, the different partitions are shown in the IBM as if the tables had different members, but we have to be careful with this. These are tables and not physical files, and this is for using SQL, not native RPG. If you are accessing this table in RPG, you must use SQL. Native RPG opcodes like chain or read won't work unless you adapt your code. SQL can access to the entire table directly. If we want to access to a specific partition, then we will need to create an alias for it. I will show it to you later with an example. Okay. Well, what about adding new partitions, removing them, changing them? Is it possible? Yes, of course, yes. We can add new partitions to our tables, or remove them, changing them. Okay. Imagine, for example, that a table has no partitions, or we have only a few, or we want to add a new one. Well, in that case, we can use alter table to add a new partition this way. Well, let me first change the partitioning of my table using the partition by range. Let me remove this and let me run this query again. Okay. Well, we can do something like this. Imagine the table is created, so we can do something like this. Alter table, the name of the table, and we can add partition, in this case number 4. Well, partition part 4, starting from, imagine, 2001, ending at max value. Okay, but look at this statement. We must be careful with adding with adding partitions, because as in this case we can overlap one partition with an existing one. Okay, we have here the partition number 3 from 1001 ending at max value. If I create this partition, we will get an error. Okay, the range is not valid. So to create the partition number 4, in this case, it will be needed to modify a partition before. So we can do it this way. Let me alter table, employees, and we are going to alter partition number 3. Okay, and we are going to write here starting from 1001 ending at 2000. Okay, and now we can add this partition correctly. Okay, well, let me now insert a new record here that we will store in this partition. Okay, so we have it in another screen. Let me paste it. Okay, so now we have all this data into the table. Okay, well, we also can create indexes over partitioned tables. Okay, we have to take care of what kind of index we want, over the complete table or over each partition of the table. For example, let me create an index number 1 on employee partitioned. Okay, what does it mean? Well, this will create an index for each partition of the table. Okay, so if we run it, employees. Okay, so we have now this index that is created for each partition of the table. Okay, but imagine that we want to create an index that spans all the partitions. Okay, then we must use non-partitioned. So we have to do something like this: index on not partitioned. Okay, so in this case we have an index that spans all partitions. Okay, well, let me remove these two indexes. Okay, and the second one. Okay, well, let's talk now about how to use all this. Okay, imagine a table that is filled with millions of records. Okay, for example, the information we are storing are orders, and we have made partitions by year. So we have millions of records of orders made in 2021, 2022, 2023, etc. Perhaps it makes more sense to run queries for these tables based on the current year and use previous years only for historical queries. For this, it's best to create an alias for the current year partition and have an alias for each of the previous years. This way, if we want to run queries based on a specific year, the database will perform searches much faster. Of course, if we don't know if we are going to use a specific partition, we can run the query directly on the table and the database will execute it without looking at the partitions. Okay, Well, for the employees table, we can, for example, create different aliases by partition this way. Create, let me, or replace alias for, and have to write here the name of the partition. Okay, it is important for this to add a name for every partition. Okay, it is important. Well, we can run it. Let me create the 4 aliases, one for each partition, okay, of the table. So imagine that we want to query over the entire table using select. We can do something like this. Well, I have it here. We can do something like this, select everything from all the table, and we are getting all this. But imagine that we want to retrieve the information that we have in the fourth partition. So in that case, we can do something like this. I am getting now only this record. That was the record that I inserted before to be stored in the 4th partition. Okay, in the same way we can do the same with the other aliases. Okay, well, great. Well, as an example, we can create a simple program using the employees table. So let me go to IBM to Code for I. We're going to remove this, and we are going to write a new program here. It's going to be an SQL RPGLE program. Okay. So let me write the first lines of the code. Oh. We are going to have a single procedure that is the main procedure. Okay, let me declare as a variable num of records that is going to be this type, and well, we are going to make a query over the entire table. Okay, so exec SQL select count everything into number of records from the name of the table. Okay, and we are going to write the result this way. We are going to write this the result to the job log. Okay, well, and also let me create a new query. Now we are going to do it the same, but from the 4th partition. Okay, so we can do something like this. We have employees with number over 2000, for example. Okay, so as you see here, I'm making a query just for the employees with a number over 2000 that were in the partition number 4. Okay, well, let me now compile the program. Okay, and let me run it. Run action, code program, and as you see, in the first query we have 6 employees. That was the information that is in the whole table, okay? And the second query, the result is we have 1 employee with numbers over 2000 because we have only 1 employee in the 4th partition, okay? So today we've covered the concept of table partitioning on IBM, exploring how it helps optimize performance by dividing large tables into smaller, more manageable parts. We looked at the 2 methods for partitioning, range and hash, and discussed how to work with partitions, including creating, modifying, and dropping them. Lastly, we saw how partitioning can improve query speed and simplify maintenance. If you want more tips like this to improve your IBM performance, make sure to like the video, subscribe, and check out my other content. See you on the next video. Thanks for watching.